So what we're going to do is now look at some data on, and I think the data is is mixed in an interesting way. So it's not overwhelmingly clear how well people do it, and they seem to do it well sometimes and not so well at others, and I don't think we understand that well why that's the case. So the first study is from 3 villages, which is not a lot, 40 households per village. They were studied for 10 years. The reason why this data was used is that it's extremely carefully collected data. So one of the reasons for you want carefully collected data is that if suppose I'm looking for insurance, so I'm going to look for whether consumption varies a lot. Now imagine the data is badly collected, not very carefully collected. Then a problem that naturally arises is that there is measurement error in the data. So the person said 10 and I wrote down 12. What will that look like when I look at insurance? What would that look like? What would that imply for the quality of insurance that I'll infer from that data?
I was going to say, doesn't it kind of depend on if it's random or not?
Yeah, let's say for in each household, you're exactly right. We go to each household, they say something and I write down something else, and I make idiosyncratic errors in every household. I make measurement error in writing down that, or I don't ask the question quite right. It's very important to ask the question correctly, and I ask it in a way that's obscure so the person doesn't understand the answer and gives the slightly incorrect answer. And I see that, let's say, household by household, I make different errors. What would that look like in insurance space? Yeah.
Well, consumption should appear less correlated than it really is.
Right. So we will see much more bouncing around of consumption if data is bad. So we need good data. The first point is that measurement error in consumption looks very much like failure of insurance. So we will over-reject good insurance if we don't have good data. That's why even though this is a very small data set, it's a good data set for studying insurance, because if your data is, so let me contrast it with something else. When I'm interested in the average of the data, I want to look at whether villages that got this technology are richer. When I'm interested in the average, then the fact that the data is badly collected is not so much of an issue for me. Why? Because, well, I'm going to over measure how much she ate, but I'll under measure how much he ate, and those will cancel out. The average is a much more reliable object than when I'm interested in the variation. The variation doesn't cancel out. If I under measure hers and over measure his, those don't cancel out. They blow up the difference. So insurance is much harder to pick up in the data than the mean. If I'm interested in the mean is okay. Usually it goes one way or the other, but the errors cancel out. Errors with insurance don't cancel out. That's the nature of insurance, right? It's exactly because I'm trying to not pick up the mean, I'm trying to pick up the variation. Okay. So the exercise we're going to do is we're going to ask the question, let's go back to income for a second. Suppose I took suppose I assume that people pool income perfectly. Okay, so they everybody takes the income of the total village, and then they get an equal share of it. Now suppose I now look at consumption of family H as a function. So I'm going to what I'm interested in is consumption of, let's see what yeah, this is alpha average income of plus beta, sorry, average income of village J plus beta income of family H in village J plus some eta, which is some idiosyncratic random shock. Maybe that family was not feeling hungry that week. So there will be some variation in consumption which has nothing to do with income. Right? So maybe they were traveling, and so they were living with their the parents, and therefore they were not spending a lot of money on food that week. Okay, so there will be some idiosyncratic variation, some source of variation which will come from average income, and some source of variation which come from their own income. Why would average income enter here? Why would your consumption depend on the average income of the village?
Is it because of that beta term over there, which is like some of it is?
But that by itself would enter through your own income. The reason why average income will matter is because I said that they're insuring each other. They're taking the average income and splitting it across the family, all the families. So if they do that perfectly, so they take average, they equalize, they take everybody's income, and then they add it together and then give everybody an equal share of that, then what do we expect alpha to be and what do we expect beta to be? Let's say there's no savings and consumption. There's no savings.
We said beta to be 0 and alpha to be 1 over n, where 1 over n.
Yeah, this is average. So alpha will be 1 and beta to be 0. We want to expect alpha to be 1 and beta to be 0. Why? Because conditional on average income, your income influences average, but conditional on the average, it has no other effect. Right? That the only reason why your income has any effect in that model where we are perfectly sharing all incomes is because your income changes the average. But conditional on the average, your income has no effect. So extreme case, we would expect alpha equals 1 and beta equals 0. Now, typically we won't find that. The interesting question is how close to alpha equals 0, alpha equals 1, beta equals 0 you are. The other extreme would be when there's no insurance. And what would we find there?
Beta
Yeah. If there's no insurance, then the average income doesn't matter, condition on your own income. The only reason average income would matter is if it were your income as a signal of your income. But once I condition on your income, your average income shouldn't matter. So basically, we have these two canonical cases, and we expect it somewhere to be in between, somewhere in the world to be somewhere in between. And the question is only how much, how much weight on this, how much weight on that. And now one case where it's one case where it's difficult to distinguish between these two theories is where these two things are very correlated. If my income almost is perfectly correlated with average income, the data is going to have a very hard time knowing which is the right model. If my income was exactly equal to average income, or was average income minus a constant, that's what's called multicollinearity. I cannot distinguish between these two scenarios. The data cannot distinguish because they are all moving at the same time. Okay, so if incomes, so the case where we will be able to have power. So what happens is when these things are very correlated, I can't really distinguish between the two cases. It's only when they're not very correlated that I have a chance of saying it's this one rather than that one.